If you've ever felt completely overwhelmed by all the crazy tech buzzwords flying around lately, you are in the exact right place. Today, we're taking things from absolute zero to demystify literally one of the most powerful forces in technology right now. We are looking at the blueprint of machine learning. Our goal for this explainer is actually super simple. By the time we wrap up, you're going to understand exactly what machine learning is, how it actually thinks, and why it is, without a doubt, the defining technology of our generation. I mean, just think about your daily routine for a second. How exactly does Netflix always seem to know the exact show you want to binge next, right? Or think about your inbox. How does Gmail miraculously filter out all that junk and spam before you even see it? Or when you just glance at your phone and boom, Face ID unlocks it. You're using machine learning every single day, probably without even realizing it. It's this invisible engine that's just silently running the modern world. So today, we're going to pop open the hood and break down exactly how this invisible engine actually works. Okay, let's dive into this roadmap for today. We've got a really clear path to understanding all of this. We'll hit 1, the invisible engine; 2, the fundamental shift; 3, the 3 learning styles; 4, the machine learning pipeline; and finally, 5, real-world impact. Section 1, the invisible engine. Let's get right into what this world-changing force actually is. All right, so before we dive into the complex mechanics, we need to nail down the definition. At its core, machine learning is a branch of artificial intelligence where computers learn from data without being explicitly programmed for every task. And I really want you to focus on that second part, without being explicitly programmed. Instead of some poor human sitting there typing out literally hundreds of thousands of strict if-then rules, we just feed the computer a bunch of data and let it find the hidden patterns all by itself. And this brilliantly illustrates the whole concept. Just think about how we learn as humans. If you're trying to teach a toddler what a cat is, you don't sit them down and hand them a written list of rules, right? You don't say, okay, a cat has pointy ears, it has 4 legs, and exactly this many whiskers. No way. You just show them pictures of cats, thousands of examples over time. You point to a cat in a book or one walking down the street, and eventually the kid's brain just organically recognizes the pattern. Machine learning works the exact same way. We feed the machine examples, and it learns the concept. Moving on to section 2, the fundamental shift. Get ready, because this is the major aha moment. So the crucial point is really seeing the contrast between the old way of doing things and this totally new paradigm. This fundamental shift changes absolutely everything. Look, in traditional programming, humans do all the heavy lifting. We write the rules, we input the data, and the computer just crunches it to spit out an output. But in machine learning, we flip that completely upside down. We give the computer the raw data, and we give it the desired output, and the computer literally discovers the rules itself. Just swapping those inputs and outputs is a total revolution in computing. Now, you might be wondering, why make this shift at all? Well, think about it. How on earth do you manually write the code to detect cancer from a medical X-ray? Or how do you write the rigid rules to perfectly understand spoken human language, with all of our weird slang and different accents? You just can't. Some problems are simply way too complex for humans to write static rules for. Machine learning solves the massive, messy problems that traditional programming just completely fails at. This is exactly why every single major tech giant runs on machine learning today. Section 3, the 3 learning styles. Let's move to and see how this builds into the actual mechanics of how machines learn. Now, what's really interesting about this slide is how it breaks down the 3 distinct, pretty easy to grasp ways machines actually digest all this data. You've got supervised learning, which uses labeled data, like for spam detection; unsupervised learning, using unlabeled data, like grouping customer segments; and reinforcement learning, which relies on trial and error, like for self-driving cars. Let's break each of these down real quick. First up, supervised learning. This is where the computer learns from labeled data. That basically means you, the teacher, hand the computer a bunch of examples that already have the correct answers slapped right on them. Because it has that answer key, it learns how to predict the answers for brand new, never-before-seen data. This is exactly what's happening when a system predicts real estate prices or diagnoses a disease. We give it the right answers up front, and it learns the relationship. Okay, the second style is unsupervised learning. Here, the machine is flying totally solo. The computer's learning from completely unlabeled data. There are no correct answers provided by humans, 0, nothing. Instead, we just dump a massive mountain of raw data into the system and basically say, hey, go find the hidden structures on your own. So if you've got a huge database of shoppers, unsupervised learning will magically group them into distinct customer segments based on buying habits, or it can even sniff out weird suspicious anomalies in banking data. And then we have the third style, reinforcement learning, which honestly is just fascinating. The computer learns entirely by trial and error. It takes an action in an environment and it gets either a reward for doing something right or a penalty for messing up. It's just a continuous, massive action and reward loop. Over millions of iterations, it tweaks its strategy to get the absolute maximum reward. This is literally how we train AI to become grandmasters at chess, how we program crazy advanced robotics, and how self-driving cars actually figure out how to navigate real traffic. Section 4, the machine learning pipeline. This is where the rubber meets the road.
So we know how they learn, but how do you actually build one? Well, every single project follows this chronological pipeline to go from raw data to a working model. Step 1, you collect your data, obviously, because without data, you have absolutely nothing. Step 2, you choose a model, picking the right mathematical algorithm for the specific job. Step 3 is where the magic happens. You train that model on the data you collected. Step 4, you evaluate its performance. Is it actually making accurate predictions? And finally, step 5, you improve it and deploy it out into the real world. That right there is the universal workflow behind the scenes.
Which brings us to Section 5, real-world impact.
I want to ground all this theory in everyday reality, because this is fundamentally altering literally every major global industry. Companies like Google, Amazon, Tesla, they run on massive applications of this exact tech right now. In healthcare, ML models are spotting diseases in medical scans with just unbelievable accuracy. In finance, it's powering fraud detection and stock predictions. Agriculture, farmers use it to predict crop yields. Transport is being completely flipped on its head by autonomous vehicles. Education is moving towards ultra-personalized learning for students. And obviously, entertainment relies on this for those insanely addictive Netflix and YouTube recommendations. It's everywhere. And the crazy part? This is just the beginning of our journey. Now that you've got the blueprint, here's what's coming up next in this Explainer series. We're going to cover the major algorithms. We're talking linear regression, decision trees, random forest, support vector machines, naive Bayes, the whole shebang. For every single one, we'll break down exactly how it works, where it's used, and we are even going to implement them together using actual Python code. We are taking you from absolute beginner to totally advanced. I want to leave you with this one final thought. Machine learning is not magic. I know it totally feels like it when your phone just instantly recognizes your face, but it's not. It is simply mathematics, data, and really smart algorithms working brilliantly together. You've just taken your first massive step into one of the most powerful fields in tech. So are you ready to learn the actual math behind it? In part 2, we are diving into our very first specific algorithm, linear regression, which is the true foundation of all of this. Make sure you're subscribed so you don't miss it. Thank you so much for joining me on The Explainer, and I'll see you in the next one.